So far in this class, we've been talking about kinematics, and specifically in one dimension. So kinematics is all the how things move, position, velocity, acceleration, time, and we've been looking at it in one dimension. So we've had lots of how position, velocity, acceleration are related, and now I want to talk about how we deal with this in multiple dimensions, so 2 or 3 dimensions. And we generally call this curvilinear motion when it's multiple dimensions. I want to talk about how we analyze these problems. So if we have some point that's making some trip through space, and here I have an x, y, z coordinate system that it might be moving through, so 3 dimensions. Any position of that particle at some time, the book uses r to denote this instead of s, so we might think about it as the radius from the origin to those points. And we can write this as some x position times the x direction unit vector, which is I hat, plus whatever the y position is times the y direction unit vector j hat, plus the z direction distance times the z direction unit vector k hat. So we could write our generic position vector as the x position I hat, y position j hat, plus z position k hat. And now all of the same rules that we've been doing in one dimension apply, but we have to keep our dimensions separate. So for example, if we know that there's an acceleration acting in the z direction, then we want to make sure we only apply that acceleration in the z direction. So much like in statics, where you might have a force in one direction and an opposing force, we can't add forces in x and y's, we can only add forces in the x direction and add forces in the y direction. So for example, our velocity in multiple dimensions might look like dx dt I hat plus dy dt j hat plus dz dt k hat. And our acceleration, same thing, now doing the double dots, or the second derivatives with respect to time. So I'm going to do this in the dot notation to save myself some writing. X double dot I hat plus y double dot j hat plus k double dot, whoops, z double dot, there we go, z double dot k hat. And now when we solve, just keeping x, y, and z straight. And I'll do an example shortly to show you how we do this. And we can either do them using the vector notation like I have here, or more common is to look at just the y direction for a little while, and then look at just the x direction for a little while, and not try to do everything in vectors all the time. Although you can do everything in vectors all the time, and also get to the same answer. So hopefully this kind of sets up how we're going to do this. Same tools we've been using, but just keeping our dimensions and directions separate. And we're not mixing x's and y's, we're keeping those x's and y's straight.